So what are the Carolina Bays?
So they're elliptical depressions that we find all over the eastern coastal plain, from south, from just under New York all the way down through the Carolinas, through Georgia. There are a few in Alabama, and then you kind of don't see very many of them until you get to around Nebraska. And then they pick back up in Nebraska, and so you have these elliptical shaped depressions in Nebraska. So they're all very similarly shaped. They all have this elliptical orientation to them. The orientation itself is actually pointing towards the Great Lakes of Michigan, which is kind of a telling sign of what they could be.
They're elliptical, and they're pointing towards the Great Lakes of Michigan.
Yeah.
What do you mean pointing?
Like they are oriented towards. They all have that.
Okay. So they're egg shaped, kind of.
They are perfect ellipses. Most of them are. You can actually mathematically outline them, and they are perfect ellipses. And the orientation itself.
Have they actually been measured?
Yeah. There's a guy we'll talk about. Michael Davies. He's measured over 70,000 of these things.
Wow.
Yeah, and measured them. Labeled them. He actually has a survey. It used to be called the Carolina Bay Survey, but now it's the Ovoid Basins Survey because he started included some depressions that we find in Texas and things like that. They're not all Carolina Bays. Plus, we got the ones in Nebraska too. So why we really need to get away from calling them Carolina Bays when they're found all over the place.
Right.
So.
Right. So what is the conventional explanation for what these are?
Well, so the conventional explanation is that they are well first of all, there have been quite a few hypotheses on what they could have been. Back in the 1930s, and I've got an image here, but back in the 1930s, when we finally had people flying in airplanes and being able to look down onto the ground overall, they first discovered them in places like Myrtle Beach. They started finding them in the Cape Fear River Valley. And they would start to take surveys. They would start to take a bunch of pictures. And back then, that's all they had was aerial photographs. And then they paste them all together. And even back then, this was back in the 1930s. And they originally thought that these were created by meteors. They thought that this was
wild.
Yeah, that they were a cosmic event. George Howard has a story about his boss when he was working on, I think it was in the Senate, his boss, the senator, had property that had a whole bunch of these Carolina Bays on it. And he told him the whole story about how, back in the 30s and 40s, man, they thought that these things were meteor holes, and they'd all go out and start looking for meteors, but nobody ever found any.
Right.
And so that kind of pushed the thinking towards more of a uniformitarianism process. Well, if they're not meteors, then they must be, something more terrestrial. It must be something, because that's what uniformitarianism is that, the terrain changes one gust of wind and one grain of sand at a time. And so the whole thought process shifted away from a catastrophic event to it being more of a terrestrial or uniformitarianism process to create these things. And that's kind of where they're at with it now, even today, nearly 100 years later, they still these are some of the hypotheses that they had come along with, from the 1930s to now. And there's a list of them here, like spring basins. At one time.
Is that on the very top right? Is that one of the Carolina Bays?
No, it's not. That's
what is that?
I think that's a crater. I think that's actually a crater.
That's an actual crater.
From a meteor, yeah. There are some people that think that they were beaver dams. And again, we're still going back and forth. This whole time from the 1930s until really the 1970s, it was back and forth with terrestrial versus catastrophic explanation for how they formed.
Extraterrestrial bays.
Yeah. So some people even thought that they were beaver ponds that were super flashed from a bolide event that took place and flash steamed the ground, causing these. Some people thought that they were giant fish or whales or something, swimming around in circles and making nests in the terrain of South Carolina, North Carolina, Georgia, and yeah.
Are there there's nothing that looks like this anywhere else in the world?
Yeah, there are oriented lakes found all around the world, and this happens a lot. Where a lot of times the oriented lakes get brought into the conversation to dismiss these Carolina bays being so symmetrical. And the presentation that I gave this past summer was called pseudo Carolina bays, because when you start looking at the Carolina bays themselves, they're so numerous. There's so many of them that they're the dominant feature. Like, they are the dominant feature on the East Coast. I would say maybe even second to like the rivers that flow along the coast. And so I've got a bunch of examples.
Can we see the ones that are used to discredit the Carolina bays? The ones that they say that. How do they use those other ones that are, and where are they also?
So most of the time, there's a couple different kinds. And like I said, the presentation I gave this summer, I kind of went through all of them. Went through a whole bunch. So here's a list that I put together of the different Carolina, or the different oriented lakes that oftentimes get used as explanations for the Carolina bays. I'll go back later and talk more about like what the current hypothesis is. But
they're not. None of them are ellipses. None of them have raised rims.
Yeah. So we have a bunch of different types. Like, this is a big one. The thermokarst lake hypothesis is that. And we do find these. You can see the images right here. We do find them up in the Arctic Circle. Yeah. In Alaska, you find them over in Russia. You also find them down in South America, like very South America. But they all occur in places where you have permafrost. And so permafrost is permanently frozen soil. So and that means that it's frozen like all year long. Only the very top layers thaw out during the summertime. The water pools in those areas, and then the wind blows them, and they start to form these circular shapes. But I wouldn't call any of those really elliptical. Now, this is an area in Alaska.
That's wild.
Yeah, this is an area in Alaska. And I could see if you were just, scanning through these images, you're like, oh, yeah, that's what formed the Carolina bays. But the areas where we find these Carolina bays are nothing like this. And even during the middle of the Ice Age, even during the middle peak part of the last Ice Age, there wasn't permafrost like this. And that's the time frame that they were saying that these were formed, the Carolina bays were formed. It really helps when you look at it with the LiDAR. And it's something that I want to kind of focus on today, is just the use of this LiDAR and how much should be progressing the research on Carolina bays. So this right here is an image of the thermokarst lakes in Alaska using LiDAR, and we don't see the same features that we see with the Carolina bays. Like, we don't see the raised rims that you would see with all those Carolina bays. We don't see that perfect elliptical shape, and the orientations are all kind of off, and they kind of bleed in together too. So when you compare that to places like this, and this is in South Carolina, it's close to McEntire Air Force Base. And again, this is just using Google Earth, which, 20 years ago we didn't really have. And so within the past 20 years, we've had Google Earth. And now within the past like 10 to 12 years, we can add the LiDAR to the terrain itself.
Oh, wow.
And now we see how many of these elliptical depressions completely cover the surface. They're everywhere.
They're so random, too.
They're everywhere. So these are Carolina bays. And
they're not all the same shape. They're all different and little.
Well, so this is kind of it's almost the terrain is steep right here. So the Carolina Bay is formed a little bit differently here, just because of how we think that these were catastrophic ice ejecta, and we can get into that in a few minutes. But the terrain here, having that steepness to it, causes it to deform as it's being formed. Another example that they often get confused with is the Playa lakes, or we find these in Texas. You also find them in places like Australia. You always find them.
Interesting.
Yeah. You always find them in river basins. Or areas where you had sheet flooding, where a tremendous amount of water flooded over the terrain, like you find in Texas. Here's an area in Texas that's kind of close to. This is the city of Amarillo. And when you look at the LiDAR of that area, right now, again, these are Playa lakes. These are oriented lakes that were created from water, as water flowed over this plain at the time. Right, so these probably formed before all of this.
This was all underwater?
A long time ago, long time ago.
How long ago?
I'm not sure. I don't know about Amarillo, how far up that was.
Wow.
But this is formed, and basically what happens is, well, I can go back to how they're formed here, where you have, it's usually very arid areas, and you have lower water tables, and so when it rains, the water pools up in areas, and then it dries, and so you get these cracks, and so the next time it rains, the water quickly goes into the cracks, fills it back up, and then, so you do end up with these like circular depressions that we see,
right?
Here.
Makes sense.
But you also see that all of them have like a low point where there's some of them still have water in them,
right?
But yeah, those aren't Carolina bays.
Okay.
They're Playa lakes.
Okay.
Here's another area in South Carolina. Again, these are going to be Carolina bays. This is close to Shaw Air Force Base. I should probably stop focusing on like areas around Air Force bases, but
what is the, to you, what is the biggest smoking gun that these are meteor impacts?
I don't think they are meteor impacts.
What do you think they are?
I don't think they are. So what I think they are, and again, I can go all the way back to that original slide with the catastrophic versus the uniformitarianism explanation. I do think that they formed very quickly catastrophically, but now, like I said, we have the better technology now with the Google Earth. We have the LiDAR, all these things added together.
Going back, you said you don't think they're comet impacts.
I do not think. I think that they're the result of a single comet impact.
You think it's ice?
Not comet impact. I would say actually an asteroid impact, but.
You think it's just ice fragments?
Yes,
that were like blasted.
Secondary ice fragments from Michigan. All of these have orientation back to the Great Lakes, back to Michigan.
Right.
And
so a comet hit, or an asteroid hit the Great Lakes ice cap, and then ejected just tons of fragments of ice.
That's what or something like that happened. Yeah.
Other than the fact that all of these ellipses are angled towards one location where the Laurentide ice sheet was, what hard evidence is there that this was ejections from a comet impact?
Well, that's where we're at now. I mean, we're trying to fight for evidence for it. Because obviously you've got the Carolina bays. They're there. The perfect elliptical shapes of them should be very telling. I'm actually right now trying to get a paper published just showing that we can prove that these are ellipses. We're using something called the least squared method. We're identifying and punching, putting dots all around the rims of these things, and proving that they're like time after time after time again, these things are actually mathematical ellipses. And you don't find things like that very often in nature. Like I showed you a minute ago, all of those oriented lakes, very few of those would actually have identical orientation to each other. Very, very few of them. Is there
anything like the like nano diamonds or any of the other materials that you find in cosmic impacts there?
So we're looking now. They have found evidence of younger Dryas stuff in some of the rims of these Carolina bays. That is one of the possibilities, is that this could have formed at the younger Dryas. I don't think so anymore, and we can get into that a little bit later. But I did for a long time think that these were part of the younger Dryas event. You guys you've covered the younger Dryas a few times,
yeah.
And I am on board that happened. I am on board that we had major fragments, bolides, blowing up in the atmosphere. We do find lots of evidence of that, and there's been a lot of back and forth with that too. And that's kind of what makes this a little bit more difficult, is because there is a connection between the Carolina bays and the younger Dryas, and the younger Dryas hasn't been proven yet fully, right? Most of us are like, yes, it happened, right? But until
it's really hard to prove.
Yeah. And the same thing with this. If ice formed it, if ice literally was ejected from an initial impact site, ice, an icicle is the perfect murder weapon, right? Once that ice melts, what are you left with?
Right.
Ponds of water.
Yeah.
And that's what.
Wouldn't there also be fragments of the rock of the comet or the meteor? Like,
if you could find it, then that would be awesome.
But that's what I'm saying. Is there any evidence of any of that shit anywhere near the Carolina base?
We've gone looking for it. Now, I think part of the reason is because nobody's looking. Like nobody's going into the apex of these Carolina bays. We tried. We actually went in. I went with
like digging right into the center. You mean?
Yeah. And I have a whole collection of sediment that can be sent off. I went with George Howard, Antonio Zamora, Michael Davis, George Howard. He was a guest on your show.
Yeah.
He used to own a wetlands reclamation company. They would be contracted out to reform wetlands, and one of his clients had a Carolina Bay on his property, and
shit.
and so he's big time into this kind of stuff. Anyway, he's actually, I call him the Godfather of Carolina Bays. George started. He mentioned it on the show with you that's what got him into it to begin with, was the Carolina Bays. And so he's always been on trying to push the Carolina Bay thing along. And so he got permission from the owner to actually, go out and dig this Carolina Bay before they turned it back into a wetland. And we went out there with backhoes and, just dug 3 huge trenches. And we just went down. He had some of his crew go down with ladders and take samples. Like anytime we saw a striation change, he would take samples out of that. We bagged that stuff up. I took it back to my classroom, and I created a lab. I actually got in touch with Alan West, who's like one of the top guys in the Comet research group. We developed a extraction protocol, which is, they already have an extraction protocol, but we had to make it high school ready, because I was using my students were doing it. And so I was working with like the number one of the top guys in the Comet research group. We developed this plan, and that would make sure that we got the same results. And we started sifting, and we started getting all of those. We got tons of magnetic grains, but the first sample we sent in, we had 3 trenches. We had one on the top, and I don't have a picture of this one, but we had one on the top, one in the middle, and then another one on the bottom of the Carolina Bay.
Okay.
So if it was like one of these, it would be on the top, middle, and then one on the bottom.
Yeah.
And this was a small one. It was one that, we can actually get into. Small is still huge. There was a whole farm there, that he was using for grown corn or something like that. But anyway, so we went through the whole process of extracting magnetic grains, and we sent them off, and nothing really stood out that it was like, younger Dryas related.
Right.
And it's super expensive. It was a couple grand. I don't have that kind of money to send these things in. George is the one who fronted it all to begin with. And like I said, we didn't get really promising results with our first go around. So we kind of put a pin on it. We halted it. And so I still have a collection set for the center trench and the southern trench that have not been tested yet, because we just don't have the money to do it right now.
Right. Well, I mean, at least for the younger Dryas, we do have some pretty solid hard evidence.
Yeah.
Like we have they've dug into the black matte layer and found shit like the nano diamonds and what is it, iridium or something they found there?
Platinum. That's what we were looking for. Because that's that one is the smoking gun. Like if you could find, platinum is a rare metal on Earth, but it's super common in space rocks, and they're finding that whole blood.
And we have the white sand stuff. Like there's so much compelling hard evidence to point to something happening around the 12,500, whatever the younger Dryas hypothesis is.
Yeah, 12,800 and something years ago.
Yeah.
Yep. And so there's a lot of evidence for that. They do find that evidence in some of these Carolina Bays, but they're like in the rims of them. A lot of times these are archaeologists that do this research. Chris Moore, and I got a picture of him on here too, but Chris Moore he's one of the leading, I think he is right now, like the leading Comet research group guy. And he's a geoarchaeologist out of South Carolina, maybe North Carolina.
Okay.
I actually went and helped him on a dig. That's Micah Hanks there in that picture. And we're actually looking for Clovis and post Clovis sites and things like that. But he's found evidence of platinum and things like that in the rims of some of these Carolina Bays, which is compelling, but not really for the formation. It just means that those rims were there while they were being occupied, and they're finding the platinum there around the same place that you would find like the Clovis people. So it sounds like the Clovis people were using these, and they were. And that's what he says, that they were really good waterfowl hunting locations, and so they would go in there looking for ducks and whatever, swans or geese or whatever, and they even find gallstones in piles where they were processing out the waterfowl and then the stones would be left behind. They used to just throw them away because they thought they were pebbles. And then somebody was like, wait a minute, these are actually like, they're from the inside of waterfowl. They're from the inside of ducks or something. And so,
oh, wow.
Yeah. So they were being used by the Clovis for hunting at that time. Which is kind of a strike against the Carolina Bays being being related to the younger Dryas. And right now, like I said, what they're finding with the younger Dryas impact hypothesis is that there probably weren't very many direct impacts into the ground, but they were thousands of bolides blowing up in the sky. It's kind of like, we go through every year, we go
like
through
air bursts.
Yeah. Like we have shooting stars. We go through meteor showers, right? And we can plan for those. We have right around the end of October into November. There's a really interesting meteor shower, and it's related to this because I think that's the one that caused the younger Dryas. But we go through it twice. It's the
torrid meteor stream.
The torrid meteor stream. So we go through it at the end of June, and then we go through it at the end of October. Right. And they think it was actually the June passing that there was just instead of it being like flakes of sand that were burning up in the atmosphere, there were chunks of stuff just blowing up in the atmosphere. We just went through a really thick patch.
Didn't this last for like 1,000 years?
Well, the younger Dryas lasted for 1,000 years.
Yeah, like it
1,200 years.
When I first was introduced to the idea, I thought like, okay, it was like a one-time event. But now it seems like no, maybe it was kind of like what we went through in Florida this past summer, where we got smashed by 2 hurricanes in a row. Maybe that happened for 1,000 years.
Yeah.
Like every summer we got smashed by meteors or comets.
Yeah, and that could have been exactly what happened. They're finding evidence that this wasn't a one-time event, that there were multiple air bursts. I always forget the name of this place, but they're finding in the Middle East. It's either Abu Huraira or Tel Al Hammam. It's one of the two. One was a bolide event that took place during biblical times. The other one was much older, like during the Younger Dryas time. And I always get the two mixed up. So maybe
George was talking about one,
and that was the one that took place during like the biblical.
I think
times.
it was the Tel Al Hammam,
right?
The one where
is that the one in the Jordan Valley,
the Sodom and Gomorrah one.
Yeah. So that was a little bit more recent than the Younger Dryas event, but there was another very similar event that took place in that area,
right?
12,800 years ago, and where literally they find melt glass like surrounding villages and like people blasted up against walls, and I mean, it's pretty insane, yeah. But I don't think that the Carolina Bays were formed during the Younger Dryas. I don't think.
Why not? When do you think they were formed?
So there's two main hypotheses for how these Carolina Bays formed. One is at the Younger Dryas, and one of the main proponents for that is Antonio Zamora. He'll be at the Cosmic Summit with me this summer. We're actually going to present together. Are you going to be there this summer?
I'm not sure.
Yeah, well, if you can make it, it's going to be a great time. Yeah, we had a good time last year.
Yeah, it was fun.
Anyway, so Antonio Zamora and I are going to be there together next year. And his main thing is that these things happened at the Younger Dryas. And he's got evidence, but a lot of the evidence is dependent on the Younger Dryas being proven correct. Things like the mega mammal extinctions and things like that. That's where he's, So he's got that idea 12,800 years ago, 12,900 years ago, that there was an impact into Michigan, and it was big chunks of ice that came flying out of Michigan. And as they came, they actually went up into suborbit, froze solid, and then came crashing back down. And these ellipses are actually the cone. The cone of depression as the ice re-entered the Earth there, and so they come crashing back down. The violence of an impact like that, even of ice, because we're talking about.
So it was raining.
That's his
football
hypothesis.
Stadium-sized chunks of ice.
Tropicana fields coming down onto the coastal plain of North America.
Christ, dude.
Yep.
And a lot of these chunks of ice had rocks frozen in them, right? Because that's what Randall talks about. These giant boulders that are in the Midwest that came from Canada or the East Coast.
Yeah, they came, but those came rafting down out on from valleys and things like that, and they came rafting down onto those areas, and then that ice, big chunks of ice that were carrying these rocks, that melted, and then you were left behind with these big rocks just kind of hanging out everywhere. I'm not sure, because we're talking about in the middle of Michigan. There was probably a really big sheet of ice there. And the only analog we really have for that now is either Greenland or Antarctica. And when you look at pictures of like Greenland and Antarctica, you don't see a whole bunch of rocks laying around. They're on the bottom, but it's almost, I mean, you have like a mile of just white ice,
right,
all the way up to the top. And I think that this, because I do agree with Antonio's like impact hypothesis. I do think that there was an impact into the ice and that it did eject the ice away from that location. They went up and then came crashing back down. I don't think they were quite as solid as he hypothesizes. I think that this, because glacial ice forms differently anyways. It doesn't form like you take like ice and put it into an ice, into the freezer and it freezes solid. Glacier ice forms when you have like annual snows that just pile up and then they get squished down. They get piled up and they get squished down.
Oh, really?
Yeah, and so you create what's called a firn, F-I-R-N, and that's when all that snow just builds up, gets squished down, and it's globular. It's kind of like plasticky, and then it eventually turns into glacial ice. So it already has like forgiveness. It like bends and it molds and it has like, I use the term plastic because that's the term that's the geologic term, but it molds and moves around and so if there was an impact into that ice, it would behave differently. It's already under pressure. It's already it's already globular, and so I think that would be highly fractured, and it would send out, and you'd have these like globs of frozen debris coming crashing back down, and it would be highly fractured. So I think when they came crashing back down, that's kind of what formed that ellipse. That's why they're so shallow. Like I said, when you look at images of these, they're super shallow in the center of them, and it's because I think that stuff came down and just kind of crashed out, and that's what gave you that ellipse with the raised rims. Again, he thinks that they were solid, and so that they were actually entering the ground, and it was the cone that creates that. And then there was viscous relaxation, where the earthquakes caused it to shake and settle back out.
Okay.
Yeah.
So the earth shaking made these things perfectly round.
No. The impact. So again, we have a paper right now that we're trying to get pushed through, but it's the cone of what's it call it? The conic section. So we have different conic sections when something enters an unconsolidated material, which is mostly sand and clay and stuff like that. And so whenever the object enters the flat plane, it creates a cone. If they were coming straight down, the conic section would be a perfect circle. If they're coming in at an angle, which these would have been, the conic section would be an ellipse. If you keep going, you'd end up with like a hyperbole, and you end up with these. There's like 4 different conic sections. These are all elliptical. We think that they're cones of depression coming in at an angle.
I see.
Right.
Okay.
And again, I do agree with that. The physics backs that up.
Right.
Yeah. So here are the cones of depression.
Yeah.
And again, you can see where the ellipses are. They're at an angle. They're entering the plane at an angle.
I see. Look at that. That is fascinating.
So again, if you imagine something entering into that flat plane, the cone itself is the object entering in, and then it seals itself into that terrain.
Yeah, it's amazing we can't figure out how to get like some sort of big drill out in the middle of those things and just drill down for like a couple miles.
we had so there's a couple things. One, we had heavy equipment, like we had a front end, what do they call that, the
front end loader,
an excavator or whatever. But yeah. And we dug as far as that thing went down, and it started filling up with water. We got as much, because you hit the water table too, and so the water just started filling this whole thing up.
Right.
We got as much sediment as we possibly could. We kind of know where the apex would be. Like we kind of know where you should probably dig.
Right.
But how far do you dig? We don't know. Like I said, I don't think that these things made it all the way down to the focus point of that ellipse. I don't think they went all the way down. I think that's something. I think that whatever happened caused it to dissipate the energy, and then you still end up with the cone of depression, but the energy is dissipated because of the material. But
so when do you think these things were from again?
Okay, so the other hypothesis that I'm looking at is Michael Davies, the guy who did all this LiDAR.
Yeah.
He thinks that these happened during the Mid-Pleistocene transition.
Mid-Pleistocene.
Yeah, the Mid-Pleistocene transition. Now this is a lot longer ago, 786,000 years ago. The Mid-Pleistocene transition is a real thing. Like we basically have a chain of events that completely changed the Earth. Literally before the Mid-Pleistocene transition, we were going in and out of ice ages like every 41,000 years. And something happened right around that time that caused a change in obliquity of the Earth that caused the ice ages to stretch out to 100,000 years. And we have this recorded in ice core data. So we were going from 41,000 years, going in and out of ice ages, to now going 100,000 years in and out of ice ages. And I'll show you a graph here in a little bit where you can see that. So, I mean, a change in obliquity is kind of a big deal, because that's one of the Milankovitch cycles, right? You've got precession, obliquity, and eccentricity.
So this thing knocked the Earth off its tilt?
Listen, you said it, not me.
If that's the idea.
I think it could be the idea. Yeah, I think it could be, yes.
Jesus.
I mean, something happened. Something happened to cause the Earth's obliquity to change, to stretch out our ice age cycles. We also find all kinds of other evidence. We find a big one for me, and you kind of mentioned this a minute ago, whenever an impact hits the ground, it's going to send up melted rock or melted parts of itself, and so it melts, but it sends these they're called tektites. It's kind of like meteorites, but they formed from the ground, from the Earth, and we find AA tektites that date back to 786,000 years, that date back to the Mid-Pleistocene transition, and it's a mystery. They don't know where they came from.
Where do they find them?
They find them all over Asia. They find them all in Australia
that are 800,000 years old.
800,000-year-old tektites, yeah, and they're found. I was just, you can go look up tektites, and they find them all over the place. And again, they don't know exactly where they came from. Now, one of the guys, there's different types of tektites. That's a good example of one right there. That was probably an A tektite found probably in the Philippines or something like that.
Wow.
But there's a huge strewn field where you find these things, and most of it's actually in the ocean. Like most of the strewn field is actually under the water, and so there's a ton of tektites that are still there. They do, yeah. I think I just saw this just the other day, where they were just finding like dozens of them.
800,000 years old, just chilling right there on top of the dirt.
Yep. And they're really kind of neat, because they actually show they were melted, they were flying through the air. When they solidified,
how do they actually know it was 800,000 years old?
It's from where they find them in the strata,
that was just sitting on top of the dirt.
Well, that dirt's been eroded away. They find them in other places that are in that location. Another thing that they've done is there's a guy who has tested those with strontium and rhodium dating.
Yeah.
And they date back to, well, actually, let me rephrase it, because they date back to the rock layers being Jurassic of age, but that's not when they're formed. Like the rock that formed, the sandstones that formed them were Jurassic age rocks, but that's what formed the tektites. What's interesting is if we look back at the Michigan Basin, the center of the Michigan Basin, right here, this pink rock right there, that's all Jurassic age rock, and so if this was an impact and we had sandstone, which most of that is Michigan sandstone, if that was ejected from that location, it would have gone into orbit, solidified, and then came back down on the other side of the planet. One of the guys that's working on this is Tim Harris. Here's Tim right here. Tim is an engineer. He used to work for Lockheed Martin and Boeing. And some of his mentors were like literally he's a rocket scientist himself, but a lot of his mentors were like the rocket scientists during the Cold War, and they use the same impact physics for like ballistic missiles to track where we find these tektites all the way back to their source. And he's been putting out papers left and right, but they just don't get taken seriously. So let's go and talk about the current academic hypothesis for these Carolina bays. Again, because I do think that they have a cosmic origin. Like I think that there was an event. Looking at the evidence, and what's interesting is you've got these two guys. You've got Michael Davies and Tim Harris, and you've got Antonio Zamora. And they're two completely different hypotheses. And Michael Davies thinks that it wasn't chunks of ice, but that it was like a cavitated ejecta regolith blanket or something where yeah, exactly. So an asteroid hit the ice sheet and just a blanket of sand and water and ice just kind of washed over and away from the impact site, and that it was more like like paint bubbles, like when you're painting and it pops and you end up with like an elliptical shape.
Yeah.
He thinks that that's what formed the Carolina Bays. To me, I don't think you would get like that that precise with the the elliptical shape of them if that were the case. So I think it's a combination of two of those. I think that it's Antonio Zamora is more on board, or I'm more on board with his hypothesis of the actual ice chunks crashing down.
Yeah.
At least the outer edge. Obviously, I think the middle part of where this would have happened completely vaporized, but it would have been the edges that came, coming out, it came crashing away, and then came down onto the ground that formed that. But again, I think there's a lot of evidence that suggests that the time frame has to be a lot older. And Tim Harrison and Michael Davies have a pretty good idea of that mid-Pleistocene, because something big happened during that time, and it hasn't been solved, and so we have two mysteries now. Because there's no make no mistake about it. The Carolina Bays are a mystery. Like we really don't know. Even the academic scientists will tell you, we're really not sure. This is our best hypothesis, right? And so when you start looking at all of the different hypotheses, you got to start pulling and taking what you can from those to kind of get a better picture. Right now, they think that the Carolina Bays were formed by wind and water. I mean, basically, it's an Aeolian lacustrine hypothesis, and sometimes they add other things too, like a solution, a dissolved solution underneath there, and water tables that rise and fall and things like that. But really, right now, the dominant academic hypothesis, pretty much, being used by guys like Christopher Moore, Dr. Moore, is that it was wind and water, that the glaciers themselves were just blowing air off the glacier across the northern North American coastal plain. Yeah. And all of the Carolina Bays would have been ponds, and it would have been swirling these ponds into these perfect ellipses, and then they just stopped. That's what they think. And it actually all goes back to a guy named Ray Kalzaworski. He was a geology PhD candidate somewhere in the Carolinas, and actually probably says it right there. No, it doesn't say it. Anyways, he in 1977 he put together a PhD dissertation where he got a sand table, kind of like what we have right here, but it would be full of sand. He made a bowl-shaped depression in the middle of it, filled that bowl-shaped depression with water, and then took a fan and blew it across the water in one direction for 15 minutes, went to the other side of the table and blew it across the opposite direction for 15 minutes. He did that for 4 hours.
Wow.
Well, I mean, to be honest, I don't know why. Like, I don't know what he was trying to achieve, because, that's wind doesn't work like that. The only reason I could think that he would like take the sand and go back and forth like that is to show like seasonal variation of winds. Maybe. I really don't know.
Still interesting.
Well, it is interesting, but this is what he got. Like, this image right here is what he got at the end of this experiment. And he made a really cool oriented lake, and I showed you images of oriented lakes earlier. And what he was trying to do in his dissertation was to prove that the Carolina Bays were oriented lakes, and to prove it, he took this bowl shape of water and created this football shape. Now, from the very beginning, I mean, he started with a bowl shape depression full of water. That's what a crater is. I mean, if you take a perfectly round bowl shape, I mean, you look at the moon, it's full of craters. Yeah. It's full of bowl-shaped depressions. Then he filled it with water and then blew air across it back and forth, for 4 hours. And
right.
There's so many variables, like environmental variables, that are left out of this explanation that it baffles me that this is still, like, this right here is like the go-to for Carolina Bay hypotheses for the academic hypothesis. 1977 dissertation that was never peer reviewed. It was never published anywhere. Went into some guy's office, and they gave him his PhD. He went on to become a oil and gas geologist. I think in Texas. Never went back to Carolina Bays. Never wrote another paper. That was it. And this is what they used. In fact, Christopher Moore has a paper. It was actually a presentation that he put together for a conference titled "Kalzaworski Was Right." And he had this whole thing about, how wind and water and things like that were they call it katabatic winds, that the winds were blowing off the glaciers. The the air above a glacier is really cold and it's dense, and so it blows off the glacier in a direction away from the glacier. And he's saying it's those winds that went over those ponds to form those perfect ellipses.
Right.
And he's done a lot of work on a specific bay called Herndon Bay. And he went through and did a bunch of, OSL dating and things like that on Herndon Bay.
Yeah.
They actually think that Herndon Bay has migrated, that it actually started here and had migrated to this point right here. It's all in that paper. Mm-hmm. The problem is, again, when you start looking at it, so here's Herndon Bay right here. This is using Google Earth. And you can see I pinned Herndon Bay in the middle. This is the one that they've done all those studies on, right?
Okay.
And again, Aeolian lacustrine, that this had to have been a pond and had to have been a pond for so long that wind and water had blown it into a perfect ellipse. That would have had to take thousands of years. And then it stopped and it was a perfect ellipse. But when you look at the LiDAR, if that's true, then it has to be true for all of them. You can't just pick one, it has to be every single one of those would have had to have been lakes. Again, this is all farmland today. This is all high and dry. These are rivers. These are all rivers of the past. But when you click on the LiDAR, you see how many or how extensive these Carolina Bays are, and they all have this. Like I said, using that least squares method, we can go on and we can pick points all around this rim.
Yeah, it's interesting, isn't it, man? It's super compelling. Especially, I know you said you don't think it's from the younger Dryas, but it's interesting to me how conventional science and academia has not sort of done more research into the younger Dryas hypothesis and tried to either validate it or invalidate it.
That's the whole point. Like, that's the whole reason why I got into this.
Yeah.
Back in 2015, I got a master's degree in geoscience. I started I wanted to teach a college level geology class. The timing was ironic because that's also the same time that Randall Carlson first went on with Joe Rogan, and I was like, hold on, and he started talking about a lot of things that made a lot of sense about the younger Dryas, and I was like, yeah. So I started focusing on and that's kind of why I went back to the Carolina Bays at that time, and then here we are today talking about them. But yeah, I definitely think that this was a catastrophic event, that these were all created at the same time. And now, like I said, I do have the credentials. I have the background now. I've taken, for some of these guys, I've taken more college level geology classes than any of them. Yeah. Like I said, I have 2 minors from Valdosta State University. That's where I went to school. That's where I first saw that first Grand Bay. And even back then, I asked them, I was like, how did it form this ellipse? Right. Because you really, when you first go to Grand Bay, you go to the top of this tower. It's like 100 foot high, and you can just see the whole swamp all the way around you. It's really kind of neat. Right. And it looks like it's circular. And I remember asking the professor, I was like, how did this form such a neat circle? And he's like, well, it's actually an ellipse. And he told me all about the wind and the water hypothesis and things like that. I was like, really? And he said, but there is also this other hypothesis. This was back in this was 2000. Right. Right. And it's really interesting because I got interested in it. I went to the internet, which back then it wasn't Google. I can't remember what it was, but I Googled or I typed in Carolina Bays, and it actually brought up George Howard's website that he talked to you about on his show. Yeah. And so I read his paper on Carolina Bays, and then I kind of didn't really think about it. I just always thought they were kind of neat. And then back in 2015, I got back into it hardcore, and it was because of papers like this 1977. I was born in 77, so 47 years ago. That paper was written, and that is the backbone. That is the bottom assumption on a whole stack of assumptions that's been built on top of it. And I think it's way incorrect. I think that there's way too many environmental variables.
Can you do a peer review on it?
It was never published. So yeah, it wasn't a published paper. So you can't do a peer review on a published paper that's never been published.
Has anyone George has published papers on this, right?
I don't know about Carolina Bays. He's published a lot of papers on the younger Dryas. Oh, okay. And that's, again, to be quite honest, like I said, I was totally on board with these Carolina Bays being part of the younger Dryas story. I was on board with Zamora's ideas. I was like, man, I think this is right. I think this is what's happening. Carlson was connecting the Carolina Bays to the younger Dryas. That's what got him involved with it. George was. Again, I'm kind of I'm kind of the odd man out now, you know, because I'm like, I don't think that they are, guys, you know, and I'm showing you why, you know, but I get a lot of pushback. You know,
it would be convenient if it was younger Dryas, right? It'd be a lot more fun.
Oh, you're not even kidding, man. Like it felt like somebody punched me right in the stomach when I was showing Michael Davies that, and I saw where they weren't, like there were none of them below that shoreline. I was like, ooh. These Carolina bays are really well ingrained into the environment themselves, and that they maintain that shape really easily for a really long period of time. And then he would use a term that it's because the coastal plain is pool table flat all the way to the beach. And I was like, Michael, it's not pool table flat. Where I live in coastal Georgia, we have ancient barrier islands. Like you literally go up 20 meters and you know, you're up on the sandhill, and there's a whole nother ecology there. There's a whole different type of ecosystem. And I pulled up his images. I went to Google Earth and pulled up his image. And when I clicked over to the LiDAR to show him, what I really noticed is where you don't find the Carolina bays, where they're missing, right? You find the Carolina bays on the tops of those ancient barrier islands, but you don't find them below them.
So where are they here?
All these red dots. This is panned way out.
Okay.
But again, this was the reason why I'm using this right here is because this is actually from a field trip guide for geology class for Valdosta State University. Okay. And so they would actually take a group of students to the beach on Sapelo Island. I usually spend about a week on Sapelo every summer helping grad students. So I'm very familiar with Sapelo Island. There's actually a really cool shell ring, like right here, shell minimum from the Native Americans that lived there. Like,
oh, really?
Like older than the Egyptian pyramids. It's really cool.
What?
Yeah.
Wow.
It's really old. And it's like right there. So anyways, he would take a crew here. They would check out the erosion and how the beach forms. Yeah. And you would look at the dunes and the different types of ecosystems as you go across the barrier island. And then they would get back on the ferry. The ferry would take you back over here to Meridian, and they would drive and they would stop at these different places. And this was one of their stops. It was like right here. You had stop one right there. And that was the ancient barrier island. So when I click on the button, that's the barrier island that was formed 125,000 years ago. You go back up, this is the barrier island that was formed 400,000 years ago. And so you end up having this like time frame of when sea levels were higher and where those beaches formed. And again, you find these red dots. Those are Michael Davies tagged those. Again, if you look a little bit closer, this is actually up closer to Myrtle Beach.
Okay.
And this is that first picture I showed you of the black and white one. This is that area today. And you can see these well-defined Carolina bays that are up here in this area. This is actually a preserve now, so there's no construction, there's no golf courses being built here, anything like that. It's all wildlife habitat. Whereas all of this down here has been like really worked over with urbanization. But what I like about this area is that where the beach is right now, the last beach was right above it, like the last time. And when you click on the LiDAR, you can see like all of these bays right here. This is the highest point on this map. You're kind of going up and then back down right here. And then you go back up and then you go way up and then you go back down and then back down. So you're going up and then back into, I can't remember what river this is back here. Okay. There's a big river back there. So this whole area right here was a barrier island 400,000 years ago. This is where we find the most well-defined Carolina bays in this picture as well. Right, so all of these are really well defined. So a million years ago, this whole area was underwater. A million years ago is when we had the Pentaholloway scarp form. So and that's like 70 meters or 70 feet above the current shoreline.
What is that? The Pentaholloway?
The Pentaholloway is the beach from a million years ago. So it was the barrier islands that are formed 1 million years ago are called the Pentaholloway.
And it was super hot then, so there was not much ice.
Definitely sea levels were higher, so it was a lot warmer. And like I said, sea levels were way up during that time.
Okay.
But that also means that all of this area was underwater.
Right.
And so everything that you see in the landscape has to be younger than a million years, which is good. That gives us a baseline,
So none of the stuff would survive under the ocean for 100,000 years?
The Carolina bays?
Yeah.
No, I don't think so.
No?
No. As a matter of fact, I don't think that they survived the interglacials, and that's kind of the point, is that whenever the sea levels rose and formed those shorelines, that erased the Carolina bays. Because you got to remember, like right now, this is the beach. You surf, right?
Yep.
So, the wave action is pretty constant, right? You have tides that come in and out every single day. You've got waves that are constantly lapping up on the beach. And you've got things like longshore drift that's constantly moving the sand down the beach.
Right.
So whenever the shorelines, whenever the beaches, or whenever the oceans rise up to this point, there's all kinds of erosion here, right? And it's just flat. It's just flat sand, right?
Got it.
So the last one was here, and I can actually, here's where I marked it. This right here was a barrier island 125,000 years ago. All of this was exposed, but this was a back bay. This was where you would find like the intercoastal today.
Okay.
Right. And so this is wiped clean from 125,000 years ago. But I also think from 400,000 years ago when this was a barrier island. And this was the upper part of that barrier island.
So that has been above sea level for at least 400,000 years.
This has been above sea level for 1 million years.
1 million years.
Yeah. The shoreline, the regression that took place 1 million years ago left everything dry. Right. And then the last time it happened was 400,000 years ago. This was still a barrier island during that time. And then 125,000 years ago, all of this was exposed, including this right here.
Oh, okay.
Yeah. So like, for instance, like this area right here on the very top.
Yep.
That's in blue. I think that these were underwater 400,000 years ago, but this barrier island protected them. And this was a marsh. I think this is like a salt marsh.
Oh, okay.
And so a really easy way to check for this, and we just need somebody to go out and do it, is to do some core samples in here. And if there's marsh mud in the middle of all these, then that shows that they were there when that marsh was there.
Right.
400,000 years ago.
Right.
And that's huge because, again, that's older than all the dates that have been coming up so far. Like even we didn't even get into the conventional creation of these Carolina bays. But theirs is, they would have happened between the last ice age, like 1,200 years ago to about 100,000 years ago. They say that during that time, during the last ice age cycle, was when all of these Carolina bays were formed. I'm saying that this shows that they're older than that. Like they're older than even what the radiocarbon dates are coming back with, or what the optically stimulated luminescence dates are coming back with. This shows that they're older than that, and so they would have to be older than that. And they're being worn away by those rising seas during that time.
How far south do they go? What's the southernmost Carolina Bay?
I find them close to where I live. They get really sparse as you get farther down into Georgia, but you do find some. There's some around like Sylvester, Georgia. The first one I ever heard of was in Valdosta, Georgia, and that's right. It's like what, maybe 2 hours north of here.
Okay,
3 hours north of here.
No, it's definitely more than 3 hours. Valdosta,
right? It's right on the Georgia border.
Okay,
if you go right up 75, you go right through Valdosta.
Yeah, I don't know how fucking fast you drive, but that's like 5 hours from me.
Is it? So, anyways, right when you cross the border, now it does get confusing, and it was part of that pseudo Carolina Bay thing because that part of Florida, you go through all of those sinkholes. Like it's all karst topography, and so you have a bunch of sinkholes. And so a lot of the geologists would mix the Carolina Bays in with being karst. Like there's actually like karst sinkholes under the ground, and that's what formed them. But this whole area shows that that's not right.
Okay.
But where I first heard about Carolina Bays was in Valdosta, because they have a Carolina Bay there called Grand Bay, and you can it's a wildlife management area. So, and they have a really pretty boardwalk, and the reason why they call them Carolina Bays has nothing to do with water. Has nothing to do with like a bay in on a coast or something like that.
Right.
They call them Carolina Bays because of the bay trees that grow within them. They're like old bay that you would use in like crab oil and stuff like that. Yeah. That's where those plants grow, is in these Carolina bays.
Oh, really?
Yeah.
Why do they grow in there?
I mean, it's just a low swampy area. So they grow. They just grow, and it's not all of them. Obviously, I showed you millions or thousands of them that don't have bays in them, but the ones that do hold water usually do have. They're low oxygen. There's low, not a lot of flow to it. And so it's a really good place for them to grow. You also find some really cool carnivorous plants in a lot of these. If you go like in North Carolina and Virginia, you're going to find like the Venus flytraps. That's cool.
Really?
Yeah. If you go to like the ones in South Georgia, you can find a lot of pitcher plants, which are just swampy plants anyways, but they really like the Carolina Bay habitats. Yeah. The ecology in the Carolina Bays are fascinating.
Carnivorous plants. What an interesting.
Yeah. Like the soil is so poor that they have to like trap bugs to get the nourishment that they need. So
That's so wild, man.